Now that we have spent some time practicing our properties of special parallelograms, we're going to use those properties in order to solve for missing variables. So, for our rectangle, we need at least one of these to be true, either 4 right angles or the diagonals are congruent. So when I'm looking at this problem, I note that I have diagonals are congruent. I see that because I have all of these congruent marks on all 4 parts of the diagonal. That's how I know that that's the property I'm working with. And I want to find AE. So AE is located here, and I know that that's congruent to BE, so that means that that equals 12. And then I want to find BD, and BD is this whole length right here. And so I know that BE is 12 and ED is 12. So if I'm looking to find the length of the whole thing, 12 plus 12 will give me 24. Let's try the same thing again. I want to find DB. DB is this whole length here, but since I know this is a rectangle, I can say that all 4 of these parts are congruent, which means all of these are 6. So if I'm looking at this whole length here, then I'm going to say 6 plus 6 gives me 12. I want to find the length of AE. AE is just this little part right here, which I do not have to solve for anything. It's already marked as 6, so AE is equal to 6. When I want to find X here, I have my rectangle with 4 right angles. If I have a right angle, that means that I'm dealing with something that is 90 degrees. So all of these are 90 degrees, which means that this 10x can be represented as being set equal to 90. So 10x and 90, they're both ways to say what that angle equals, but I need to figure out what x is, and that's when I'm going to solve my equation. And when I do, I find that x equals 9. So now we're going to look at a rhombus. For a rhombus, we have 3 different properties that we are going to explore. So the first property that I have is that the diagonals bisect opposite angles. And remember, I talked about how we were going to use our colors, and we could highlight the diagonal so we can easily visualize that all 4 of these angles must be congruent to each other. And then I'll do the same thing with the blue line. All 4 of these angles must be congruent to each other. So once you use your colors, it's very easy to visualize exactly what we're looking for. We want to find x. Well, x I've highlighted pink because it's on the pink diagonal, so it's congruent to this 30 degrees. So x equals 30 degrees. Let's do the same thing here. We're looking at the diagonals are perpendicular. So if I know the diagonals are perpendicular, I know then that all of these center angles must be 90 degrees. So x is 90 degrees. And this is true for my rhombus. When I am looking to find y, well, let's take a look. I can see that I have these 2 diagonals, or this one diagonal has these 2 angles, and then these 2 angles over here. All 4 of those are congruent to each other because they all touch that diagonal. I could do the same thing with this one, but I don't know any information about any of those angles at this point. So all I needed to know to find y was that that 20 and the y are congruent. So y equals 20 degrees. So let's go ahead and look at one that's a little bit more complicated here, using these exact properties. So first thing first, We always know in a rhombus, because this problem tells me I'm dealing with a rhombus, that I have my diagonals are perpendicular. So if they are perpendicular, that means that all of these are right angles, which means that A must equal 90 degrees. Then, when I'm dealing with a rhombus, I know that all 4 of these angles are congruent, and I know that all 4 of these angles are congruent. So I've got my purple diagonal with its 4 purple angles, and my green diagonal with its 4 green angles. And so when I go ahead and I'm looking, I see that 65 must be congruent to B because they share a diagonal. And that property, remember, is that diagonals bisect opposite angles. And then when I'm looking at my green diagonal, 25, this is going to be congruent to all 4 of those parts. And so that's going to be congruent to C. So C is equal to 25 degrees. Now, what if we use the property that says we have 4 congruent sides? Well, that means that if this side is 6, that this is 6, and this is 6, and this is 6. So when I'm looking to find BC, the length of that must be 6. Finally, the last shape that I'm looking at is a square. When I am dealing with a square, I know that I have 4 right angles and I have 4 congruent sides. This "and" is very important. If you don't know both of these things, 4 right angles only tells me that I have a rectangle. 4 congruent sides only tells me that I have a rhombus. Together, they tell me that I have a square. So here, I know it's a square because I'm telling you that at the beginning of the problem. So even though you don't have the 4 right angles marked, you still know that this is a square. It has 4 congruent sides. So that means that if I want to find the length of BC, it has to be equal to that 14 because all the sides are the same length. Here for my square, I have 4 right angles. It is a square once again because it tells me that it's a square, even though I don't see that those 4 congruent sides are marked. Anytime we're dealing with right angles, that means that I'm going to be setting it equal to 90. And I can go ahead and solve. So x is equal to 30.